Hey everyone, here we have a multi-part problem. In part A, on the axis below, we want to sketch the graph of y equals the absolute of 6 minus 3x, showing the coordinates of the points where the graph meets the coordinate axis. In part B, we'll solve the absolute value equation. And in part C, we'll solve an absolute value inequality. What I like to do in absolute value graphing problems is find the vertex. So if our function is in the form y equals absolute x minus h plus k, the vertex will be hk. Our function is not quite in this form, so we're going to need to change this a bit. Let's write our function. Y equals the absolute of negative 3x plus 6. I'll take negative 3 as the common factor. So we can write negative 3x minus 2, which can also be written as absolute negative 3 times absolute x minus 2, which gives us y equals 3 times the absolute of x minus 2. As we have a 0 here, we can say that our vertex is 2, 0. So we can mark that on our graph here, 2, 0. Then we just choose some other x values to draw the graph. So when x is 3, we'll have 3 for the y value. When x is 4, y will be 6. When x is 5, y will be 9. All I'm doing is substituting some x values into our original function. So this branch of our absolute value function is here. This graph is symmetrical about x equals 2, so we just repeat our values on the left side. So this value would be 3, and this value would be 9. So we can draw our graph in here. And we should label it y equals the absolute of 6 minus 3x. In part B, we need to solve the absolute value of 6 minus 3x equals 2. One possible approach is to graph y equals 2 onto our graph and find the intersection point. So let's try that. Here we have y equals 2 here. The problem we have is that we can't see exactly what these points are using the graphical method. So we just use an algebraic method to solve this. So for this part inside the absolute value sign, it must equal 2 or negative 2, because absolute 2 is 2, absolute negative 2 is also 2. So for the first part, we can write 6 minus 3x equals 2, 3x equals 4, so x equals 4 on 3. And that gives us our first value here. So this is 4 on 3. For the right branch, 6 minus 3x equals negative 2. So we'll have 3x equals 8, x equals 8 on 3. This is intersection point here. So this is the point 8 on 3. So these are your solutions for part B. In part C, we want to find the values of x for which the absolute of 6 minus 3x is greater than 2. So we can do that by looking at our graph. We can see that our absolute value function is greater than 2 in these regions here. In the same way, we can see our absolute value function is less than 2 in this region here. So our final solution, we can say that x is going to be greater than 8 on 3, or x is less than 4 on 3. For those intervals, this inequality will be true. Thanks for watching.